or a polynomial is multiple monomials put together. So this could be x, this could be 3x, this could be 12, this could be 13ab. By definition, a monomial is either a numeric number, a variable, or a product of those things. So it's either a number, a variable, or a product of those things. Okay? So x is a variable, 12 is a number, 3x, 13ab, those are products of variables and numbers. It might even look like this, 2/3 x, product. And a polynomial is multiple monomials combined. Monomials combined. So if I took all of this chaos that I wrote over here, x plus 3x plus 12 plus 13ab plus 2/3 x. This is a polynomial. Okay? There are a couple of special types of polynomials. There's a two-term polynomial, like say x plus 12, which would be called a binomial. And then there's three-term polynomials, x plus 13ab plus 12. That would be a trinomial, based on the number of members at the party. Bi 2, tri 3. Okay? But if you don't want to specify how many there are, polynomial do the trick. Now, to simplify such things, to simplify them, we combine like terms. And in that example that I wrote up here, the only things that are the same is 1x, 3x, and 2/3 x. Combining 1x with 3x with 2/3 x will lead you to a simplified x. 4 and 2/3 x, which you would generally keep as an improper 12, 14/3. I know that sounds silly, but that's just how it normally is. So we would combine our x's and then bring the rest of the data down. This is the simplified form of this. A polynomial is simplified when you can't combine any more terms. So that takes us to example 1. Negative 3x squared added to 5x minus 2x plus x squared minus 4. So when you have all these different things, you have to recognize what is the same. And if there are exponents involved, you see the square? By the way, 2x and 5x have an exponent of what? Well, it's not none, it's actually 1. You just don't write it. Good guess, though. That's a little better, isn't it? Whenever you are asked to simplify, start with the highest exponent. If there's only one letter, the highest exponent of the letter you have. The highest exponent is these. By the way, there's no number in front of this, but that means it's a 1. Would you agree? So we are going to combine the 3 positive, the 3 negative with the 1 positive. 3 negative, 1 positive. So how many x squareds does that leave us? Negative 2x squared is right. Once you're done with those, go to the next exponent, which is x to the first. And when I say highest exponent, I'm talking about of the variable. Because you could say to yourself, well, this is technically 4 to the first power, but highest exponent of the variable. So 5 and negative 2. What's the result of combining 5 with negative 2? 3, which means there are 3 x's. Is there anything to combine the negative 4 with? There's your answer. Everything combined, nothing else can be done to that. By the way, exponents are related to a term called degree. And we're going to see that here shortly. You're going to see what the term degree means here in a second. But before we do that, I want to look at example 2. Go ahead and look at the book for a second, and then I'm going to do mine with you. Take a quick look in the book. Example 2 says, write the sum of the areas of the rectangles as a polynomial in simplest form. All right. Let me label the sides. Should be fine. Okay. Tell me the area of rectangle A. Anybody have any idea? 4x squared, good. And you can presume, guys, that this is 5x and this over here, because it's right next to that, is also 2x. Okay? So let's do rectangle B. What's rectangle B? 10x squared. Awesome. How about C? Yeah. And you can assume that this is the same as this, which would be 2x. And we'll call that rectangle D. What's D? 10x, good. And those are all positive numbers, right? Let's simplify all of that. Let's simplify it. What do you get when you combine your x squareds? No, not to the fourth power. You're not adding exponents. Right. 25 x's combined with 10 x's. 35 x's. By the way, speaking of degrees, the degree of a monomial is the sum of the powers within the monomial. So the degree of this monomial is 2. The degree of this one is 1. X to the first. If I ask you for the degree of the overall polynomial, it's the largest degree within, which is a 2. I'll show you another example of what that might look like here real quick. You could read more about that on the bottom of 146 and the top of 147, but I'm going to do a couple more real quick. Degree of 13x squared y cubed z to the first. Now this big honkin' monomial has 3 exponents being, or 3 variables with exponents being multiplied by that 13. This is example 3. To find the degree of the monomial with all these exponents, add the exponents together. Should be a 6. The degree of 13x squared y cubed z1 is 6. The degree of that polynomial is 6. Okay, examples 4 and 5, and this is where it gets a little bit tricky. Example 4, not so much. We're going to add together polynomials real quick. This I don't feel is too difficult. We'll do, 6x squared minus 3xy plus 2y squared. And we're going to add that to 3x squared minus 3xy plus y squared. So we're adding. So that just basically means combine, right? And you're combining like terms. The 6 and the 3, lucky for you, are already stacked right on top of each other, and they're the same kind of thing, aren't they? They're x squareds. So after you combine the 6 with the 3, how many x squareds do you end up with? 9. How about the second one? What do you end up with? Good. Negative 6 xy's. How about the last one? 3? 2 and 1. Yep. Okay. Subtracting. I'm going to take the same problem and make it a subtraction problem. 6x squared, negative 3xy plus 2y squared. I'm writing it again, minus 3xy plus y squared. So to subtract, this is huge. And if you're not paying attention, I'm going to be writing this on your papers. Add the opposite of all the terms in the subtrahend. So this is minuend. This is subtrahend. And the result is the difference. You guys probably haven't heard that term in a long time. Minuend, subtrahend, difference. So to subtract, add the opposite of all the terms in the subtrahend to the top, to the minuend. So here's the subtraction symbol. Add the opposite of 3x squared. Add the opposite of negative 3xy, which is positive. Add the opposite of positive y squared, which is a negative. So in effect, you are flipping the signs of the three pieces of this polynomial, and then you just add. 6 and negative 3, what do you get? 3x squared. Positive 3, negative 3. How many xy's do you end up with? None. Positive 2, negative 1. 1. There's your answer. Okay, but this has to. You have to do it. Now, sometimes they might say to you, subtract something like this. Subtract this from that. So which polynomial is the minuend? Which polynomial goes on top? No, look at it again. We're removing this from that. Okay, be very, very careful as you read these. Don't assume that that's the order. Read the words, because you will have some like this. So that means I'm going to write it like this. Okay. What am I going to do? Add the opposite. So what do I do with the signs in all the subtrahend? Flip them. The positive 2x squared becomes a negative. The positive xy becomes a negative. The negative 3y becomes a positive. Once you've done that, treat it like addition. Go ahead and solve it. Tell me what you get. Did you get 2x squared in the first position? What'd you get in the second position? Negative 4xy. And what'd you get in the last position? Good. There's your answer.